Many professional health guidelines focus almost exclusively on a single number, 7 hours of sleep, but using total time as the primary metric for recovery ignores the actual mechanics of human biology. The body does not recognize a cumulative clock. It relies on an uninterrupted sequence of biological phases. These two hypnograms represent 7 hours of sleep. On the right, we see a smooth, healthy progression. On the left, we see a fragmented cycle, where the sleeper frequently drifts back toward wakefulness. This fragmentation prevents the brain from reaching the depths required for systemic repair. Even though the 7-hour goal was met on paper, the biological utility of that sleep is essentially lost. Total duration is a deeply incomplete metric unless it is paired with structural integrity. A 2022 longitudinal study by Smith and colleagues investigated the long-term consequences of this structural failure. The researchers tracked over 7,000 subjects over several years, specifically correlating their objective sleep quality with their overall lifespan. Their findings revealed a significant divergence. High-quality sleep cohorts showed a 5-year advantage in longevity compared to those with poor sleep architecture. This gap represents an extension of health span, the period of life lived without the burden of chronic, debilitating disease. To capture this biological advantage, we must look past the total time on the clock and understand the physiological architecture of the night. Sleep is not a passive state of silence. It is an active, oscillating biological process. Throughout the night, the brain moves through a macrostructure, alternating between rapid eye movement, or REM, and non-REM states. This waveform shows a healthy cycle descending from surface consciousness into deep restoration, then climbing back to REM. Non-REM sleep is categorized into 4 distinct stages of increasing depth. The deepest valleys on this graph represent stage 3, known as slow-wave sleep. This specific depth is the exclusive biological territory where the body performs its most aggressive tissue and metabolic repairs. The longitudinal data suggests that the density and stability of these stage 3 valleys are vital factors in securing the 5-year health span extension. One of the primary difficulties in sleep science is that humans cannot consciously track their own progress through these stages. Researchers often use the Pittsburgh Sleep Quality Index to capture subjective data, such as how long it takes to fall asleep or how efficient the sleeper feels. However, subjective indices are limited. Feeling tired in the morning doesn't reveal the specific moment the sleep architecture failed. For objective data, clinicians use polysomnography. This provides a detailed readout of brain activity and muscle movement, allowing for a precise analysis of sleep cycles. Systemic optimization requires moving past subjective feelings and analyzing sleep through the lens of objective electrophysiological data. For middle-aged adults, the most significant output of stage 3 sleep is metabolic regulation. A 2008 study by Tasali and colleagues established a direct correlation between the quantity of slow-wave sleep and metabolic health. During deep non-REM sleep, the human body undergoes a crucial recalibration phase, dramatically increasing the sensitivity of insulin receptors. This enhanced sensitivity allows cells to absorb glucose more efficiently, which prevents chronic systemic inflammation. When this mechanism fails, it results in an exponential rise in the risk profiles for obesity, diabetes, and cardiovascular disease. Stage 3 effectively operates as a daily metabolic reset switch. Skipping it leaves the endocrine system running in a degraded state. In older adults, the focus of stage 3 shifts toward the maintenance of the central nervous system. Standard brain activity during the day produces toxic metabolic byproducts, and proteins as a byproduct of neural firing. In stage 3, the brain triggers a mechanical process where cerebrospinal fluid rushes through the tissue, physically flushing out this accumulated waste. This clearance is the brain's primary defense against cognitive decline and the progression of neurodegenerative diseases like dementia. Even short-term disruptions to this process can degrade mental health, increasing the risk of depression and anxiety disorders. Without the neurological wash cycle provided by stage 3, the brain is left to steep in its own metabolic waste, which can accelerate cognitive aging. You cannot consciously force your brain into stage 3 sleep. To optimize this process, we must use an engineering framework, controlling the conscious input variables in our environment to trigger the subconscious response. The first variable is light. Eliminating blue spectrum light 1 hour before sleep triggers the secretion of melatonin. the chemical signal for the night cycle to begin. The second variable is ambient temperature. Regulating the environment to between 16 and 19 degrees Celsius facilitates the drop in core body temperature required to sustain deep non-REM sleep. The third variable is physical exertion. Regular movement increases sleep depths, provided the resulting spike in cortisol doesn't occur too close to bedtime. Sleep optimization is not a matter of willpower. It is a result of intentional environmental design and biological programming. Small, consistent adjustments to these variables produce massive systemic outputs over several years. These outputs are what accumulate into the 5-year health span advantage. By managing the input variables of light, temperature, and movement, we facilitate stage 3 architecture, leading to increased metabolic and cognitive health. When the environment is set correctly, the body secures those 5 extra years of health. Longevity and peak biological function do not come from simply spending more hours in bed, but from mastering the deep, hidden architecture of the time we spend there.